All right, guys, welcome back to automation and scripting for the IT professional. We're going to be talking about chapter 12 today. And so, in the last chapter, we talked about how to connect our ESP32 to a Wi Fi network. Now, we're going to take the next step and actually connect it to the wider internet. This chapter is all about network programming, and we're going to be using the universal language of HTTP, which you all use today to browse the internet. Now that our ESP32 has an IP address and the ability to communicate, in this chapter we're going to dive into the practical code needing to make that happen. We're going to explore how our ESP32 can both act as a client and by fetching data from the internet, and as well as a server by housing its own web pages for local control. We'll start by looking at the ESP32 role as a client. In the client server model of the web, the client is the one that makes the requests. By acting as the client, our ESP32 can perform two major actions. For one, it can fetch data. Okay? And so this is like getting data from like time or weather from a web service by getting GET requests. Now it can also send data by submitting sensor reading data to things like a POST request. To make these HTTP requests, we don't have to start from scratch. MicroPython provides us a fantastic library called uRequests. Okay? It's like a micro version of the main request library, but it's smaller. Okay? Now, it makes the process of making web requests very, very simple. Now, all we need to do to use it is import the uRequest at the top of our script, the module itself, or the library, and we can then call it upon in our scripts. A GET request is how we ask a server for information. With the uRequest library, this is as simple as doing a GET function and passing it the URL of the resource that you want to get. In this example, we're going to define a URL that points to a public time API and then do a uRequest.get to fetch the data. The server is going to then reply in a response object. So after we make that request, the server is going to reply with the response object. The first and most important thing is to check the status code. A status code of 200 means everything was successful. If it's something else like 404, not found, we know there's a problem. If the request was successful, then we can then access the data by using response.text. This is going to give us the raw text, and if the data is come in a JSON format, we can even do a response.json. Now, the greatest thing about using the JSON format is it will automatically parse it into a Python library, which is very easy for us to work with. But if you do use the JSON, just be aware you may have to import the JSON library at the top of your script. Now, the response.close is a very critical step. It's very important when we're working with microcontrollers because we have very limited resources of memory and network resources, so we need to explicitly close the response object when we're done calling it, and we'll do that with the response.close object. If you forget to do this, you can quickly exhaust memory on your ESP32, which then will prevent us from actually functioning any more in the future or any other network requests until we reset the board. Now, I like to use a try finally block here. This is the best way to make sure this is always happening. And so we'll talk about that in a future slide. Now, for the other side of the coin, a post request, we can use the post request when we want to send data to a server. This is how we're going to send like our sensor readings to the stored from our database or into a web service itself. And as you might guess, it's going to be uRequest.post to do this. The most common way to send structured data like sensor readings to a modern web service is using the JSON format. The uRequest library makes this incredibly easy. You can just create the Python library with your data and then pass it to the post function using the JSON parameter. The library itself is going to handle all the work for us and apply our dictionary properly into a formatted JSON payload that we can send to a web server. Now, one thing you can always count on with networking that it will eventually fail. Your Wi-Fi might drop, a remote server could be down, or a URL just might be incorrect. For this reason, it is absolutely essential that we wrap all of our network requests with a try except block. This allows us to catch any potential errors gracefully, handle them, and prevent our entire script from crashing just because of a temporary network hiccup. So far, we've been a client, but the ESP32 is very powerful enough that it can even flip the roles and become a simple HTTP server. This means it can listen for incoming requests from our devices on our local Wi-Fi network. This could be things like your computer or your phone, and then send them back web pages in response. So why would we want to do this? Well, it's incredibly useful for local control and monitoring. We can create simple web pages with buttons that allow us to turn an LED on or off from your phone's browser. You can serve a page that displays the live readings from a temperature sensor, or you can create a local configuration portal for your device, allowing you to change settings without having to reprogram it. It's very powerful. Okay. At the lower level, a communication is all going to be handled through what we call a socket. A socket is an endpoint for sending and receiving data, and to act as our server, our ESP32 script must use the uSocket module to create a socket, bind it to its IP address, and listen for incoming connections. This is how we're going to create our web server. The workflow for creating a web server on a continuous loop is as follows. First, we need to create a socket and bind it to port 80, the standard port for HTTP. This is what's going to listen for connections. When a client like a web browser connects, the server accepts the connections, and then it's going to send the HTTP request, processing it, and then give it what the server or the client wants. And then it's going to send it back as an HTTP response, which usually will contain the HTML, the web page itself, and then finally it will close the connection and still listening for the next client. To make our web server interactives, we need to parse the information from the web browser. A simple way to do this is look for specific strings in the URL. For example, if we design a web page, we can click on a button that makes it request a URL containing LED on. Our ESP32 code will simply search for a substring that it knows about and then turn the LED on. The web page that the ESP32 servers doesn't have to be static. We can make them dynamic. This means our MicroPython script can check current status of hardware, for example, like is the LED on or off? It can then insert the status directly into the HTML string before sending it to the web browser. This allows our web page to always reflect the real-time state of the device. All right, so for this lab today, we're going to demonstrate this in both of our roles. In part one, we'll act as the client by doing GET requests to a world time public API and get the current time. And then in part two, we're going to post our sensor data to a Google Sheet using a custom Google Apps script to act as our own personal API. Now to summarize this, we're going to take these skills and use our ESP32s to be a participant of the web. We can now be a client or we can be a server. And when we do that, we're going to be using things that we use through the uRequest library, because this is going to act as our HTTP server and provide us a local web interface for control and monitoring, as well as giving us the foundation to build even more powerful IoT projects. All right. That was the end of this chapter. Quite short. Take your time on this lab. 12.1 is one of my favorite labs in the entire course because it really is useful. It teaches you how to get information from the internet, maybe time, maybe the weather, and then we can use that information further into our scripts. The hardest part of understanding this is how do we get the data in the first place? Once we have the data, then it's easy to build a circuit that can be helpful in our life. And then it's always great to be able to post data back to a web server, including Google Apps or something in that nature. And so if we wanted to keep a record of how warm our living room is or something like that, it'd be real easy for us to make an IoT device that will monitor the web and then just periodically post that information to a Google Sheet, which then we can track upon and use that information for whatever purpose we need. All right, I'll see you for chapter 13. Good luck programming.